Hey everyone, and welcome back to another episode of Practical Parallelism in C++. My name is Nick from Coffee Before Arch, and today we're going to take another look at a basic example of multi-threading in C++. But this time, instead of using standard thread, which abstracts away the actual implementation of the threads that we're using, we're going to specifically be targeting a Windows platform. And so there may be specific things that we can do, especially if we know what type of threads we're working with, that we can't do if we're just assuming we're using standard thread, which abstracts, the actual implementation away from us. So, like I said, in this video, we're going to be using the Microsoft version of Threads. In other videos, we'll go over stuff like OpenMP, MPI, which uses different processes, and then stuff like pthreads in a Linux environment. So let's go ahead and jump into the example for today. So we're going to make a C++ program, and we have a couple new includes that we need. So we actually don't need this IO stream at all. So we need two new includes. We need this windows.h, and that's what we'll get all of our Windows-specific functions and types from. And then we need this string, this strsafe, which is a string safe, and that's where we'll get a lot of our string operation functions from. So let's just briefly go over some of the functions we have here. So we've got, first of all, not a function, we've got a struct, and this is just going to be what we're going to pass to our thread as an argument. So we're going to print out the thread ID, and then we're going to print out a number, and that number will just be the thread ID squared, so thread ID times thread ID. Then we're going to have this display message over here. We're going to have the actual function that will be the entry point for our thread, and then of course we'll have a main function. So let's actually start at the main function and build our way up. So starting out, we already have a new data type, and that's this handle. And you can think of handle a lot like a pointer. So here we've got a handle to an object. In this case, we're going to create an array of them, so we're going to have an array of handles. And we'll eventually use this for threads. So thread in this, num threads in this case is 10, so we're going to launch 10 threads. And we'll just initialize them to 0. Doesn't really matter. This is going to be overwritten later. And then, because we're making 10 threads, we have 10 arguments we want to pass in. So we'll go ahead and make an array of 10 of these structs package. So then we'll actually create our threads. And so we'll create our threads just in a for loop. So we'll just loop from 0 to 10. We'll initialize package to just be I, so we'll have 0 through 9. And then we'll initialize number to be whatever I squared is. So it'll be 0, then it will be 1, and then it'll be 4, etc., all the way to 9, which will be 81. So then we get to something new. We get this create thread. So we saw that how to create threads using just the standard thread in C++, but now we're going to be using this Windows-specific implementation of threads, and so we have to actually manually call create thread. So create thread has a lot of arguments, but we're not going to use a lot of them. A lot of them we can just leave default, but there may be circumstances where we can, better tune this as we need to, something that we can't do if we're just using standard thread. So the first thing is these security attributes of this thread. So we won't get into exactly what that is, but we can, when we leave it as null, it will just default to the normal attributes. Then stack size, we'll set it to 0. Now this doesn't mean we have a stack size of 0 for the thread. This just means that we'll use the default stack size. Then similar to when we had to define an entry function for a standard thread, we have to do the same thing for this create thread. And so here we're going to be launching boring thread function, which is just what we named this function right here. So, all right, so that's that. And then we have an argument. So this is going to be the argument we pass in. Now, specifically for Windows threads, they don't take, you can't, say pass in, a whole bunch of integers or something. It takes a void pointer only. So that means we can pass in a pointer to whatever we want. So we'll pack our arguments, which are these two things, inside of a struct. we'll cast the struct as just a void pointer, and then on the other side we'll cast it back to being of that struct type of package. And so we'll just pass it its own version. And then we have a creation flag. So this creation flag, we can either have the thread run immediately, which is what happens when we set it to 0, or we can say have the thread, we'll create the thread, but the thread doesn't start. So we can also do that. And then finally, we can have a pointer. We can give it a pointer to a variable, and that variable will be filled with the ID of the thread that we launch. Now, in this specific case, we don't care about the thread ID. We don't care about the thread ID from the main function, or the thread ID given. We're not going to do anything if we pass back that thread ID to the main function, so we'll just leave it null and we'll ignore it. So that's going to be it as far as launching the threads go. Now let's see what happens after we launch the thread. So all these threads will start right here. And so we've got a couple things. So the first thing that we need to kind of discuss is this D word. Now, D word, we actually have it up here as well. D word is just a Windows specific type that's unsized 32-bit. And you'll see a lot of things that you can trace back to normal C++ types. So there's also this LP void right here, which is just a void pointer. But the reason why Windows has its own specific types is because a lot of these things in the C++ standard, they're not directly specified as being, say, 16 bits or 32 bits or 64 bits. It'll say be, less than or equal to, or rather greater than or equal to a certain size. I think the only thing that's actually specified is that a char and an unsized char or character will be a single byte. But other than that, we don't really have, guarantees. And so if we're working with a specific implementation or an operating system, a lot of times, so in this case, the operating system will specifically tell us, hey, use this type instead. This type, we're going to provide some guarantees for you that the language does not. So then we also have, so LP void is another version of this where it's basically just a void pointer, but it's in the Windows semantics. And the basic idea when you're doing programming in a Windows environment like this, and you're going to be working with these types of utilities, you generally take the win and roam kind of philosophy. So if you're going to be working in a Windows environment and doing these types of things, use the Windows data types. That's just to guarantee correctness and get expected results and not mixing together C++ and Windows things if they overload each other. So the other thing we have here is a macro, this win API. And all that this does is it says you're just going to be using the Windows calling convention for this function right here. So nothing, we don't need to dig into exactly, at this moment we don't need to really understand what that means as far as, a calling convention for a function, but we'll just know that, like I said, win and roam. So then what do we have inside of here? So first thing we do is we cast this void parameter back to being a struct, and we copy it into this local version. So then after that, we create a handle, which, like I said, we can think of as a pointer. And then we want to get, specifically want to fill that handle with a pointer to standard out. So kind of like we have cout, which we have an object to send stuff to standard out. We can also get, this pointer or handle, we should call it a handle. We should get this handle to standard out. And we do that by doing get standard handle, and then we just specify which handle. So there's all of these are kind of like predefined for Windows inside of this windows.h. And so we'll just get the one to standard out. And then we'll go ahead and call, just like a normal function, this display message, which is above, and we'll pass it the handle to standard out, the TID, the number that both came in that package struct, and then we'll pass it a string that just says hello there. So finally, let's go to our display message. So again, another data type. This time it's going to be tchar. So again, kind of like we have dword, which is unsized 32-bit data type, and we have LP void, which is void pointer data type. So tchar is just going to be like a character data type. And we'll just make an array for a specific buffer size. We want to print out a message, and we're just going to tap the buffer size. And then we're going to have size t, which is part of C++ and C. And then we'll make another D word, which is, again, is a Windows-specific type that's unsized 32 bits. So then the next thing we're going to do, we mentioned in the previous couple videos when we were printing that things like printf and things like cout weren't something that I said were thread safe, and that's mainly because C++, until the C++ 11, it didn't even have that standard thread. So C++ in itself doesn't know anything about thread implementations. And so because of that, how is it supposed to know that, what to do when multiple threads are trying to access something? So over here, we've got a better guarantee. So we have thread safe functions that we can use. And so we can use these to, print out without having to use what we did last time, which was a mutex lock, or a mutex in order to, lock that critical section, print out from one thread, and then everyone else is kind of spinning, waiting to get that lock. So over here, we don't need to do that. So because this is thread safe, it's built in, it does it for us, that locking critical section for printing, so we don't need to worry about it. We do have a couple new functions here. So we've got this string ch printf, and so this is just going to print a string into a buffer. So we've got this buffer we allocate up here, this array. We're going to, we specify the size, and then we use this text in order to, this is going to take our, this string that we have right here. So this printing number, and then we'll do an int from thread, which will be another int, and then that string that we pass in, and then a new line character, and then TID number and message will get filled in where all of these specifiers are. And so this is just going to create our string and print it into this message buffer. Another thing that we'll do is we'll do this string string c ch length, and then what that'll do is it will check the message buffer against the buff size, and then use this size t thing, and it will check basically for an overrun. So this string size will either be the size of this message that we have here, or it'll return something like null if it's an error. So it'll fill this. So that's why we pass in an address. So it'll fill this, and that's what we'll send to write console. So write console. This is just kind of a check here. So we're just doing this little check to see if there's a buffer overrun, and then we can use whatever gets filled into this variable as our check. So then we'll actually write console. So this will actually write to standard out. So in this case, we're passing in this handle to standard out here to the screen. Then we're going to give it the message buffer, how big the message is. Now this will, in this case, we're less than 255 characters that we specify up here. So we shouldn't get any errors. Both of these will work correctly. And then right here, this DW char is similar to how this will fill the string size with the size of whatever's in the buffer. This will fill in how many characters get printed out to the console. And then this last spot is reserved, so we just fill it with null. And then we'll just put it to sleep for a little bit. But that's overall the picture. So again, kind of the flow here is we create threads, and we save the handles. So the handles is basically kind of like a pointer to the thread. And then up here, inside of this boring thread function, we unpack our arguments that were in a void pointer. We get a handle to standard out. We pass that to display message. Display message fills a message buffer, which is a character buffer or character array, with a message that we want to print. We check it and fill this CCH string size with the size of the message. Just remember, it doesn't get filled with the size of the message if it's too big. So we use this check for buffer overrun, which is a common security exploit where we try to go past the end of a buffer. And then we write it to the console here. And again, this is thread safe, so we're not going to get any intermingled text when we print it out. And then let's go back down here. So after we printed out everything, we'll go ahead and call this wait for multiple objects. Now, wait for multiple objects is kind of a synchronization barrier. So what it says is I want to wait for 10 threads, then I pass it an array or a pointer. So I pass it this an array of handles here, and so it'll check all of these handles that I'm giving it based upon this number. It will check to see, and then wait for multiple objects, it will check to see if they get, wait for a number of threads to be in the signaled state, so when they finish. And then we can either specify it to wait for a specific amount of time or just wait until they're all finished. Okay, so that's going to, or we can wait for a particular number. It doesn't have to be all the threads. It can be any of them. Or it can be a certain lower number. So we can wait for, say, 5 threads to finish and then continue on. And then finally, just kind of like when we free stuff at the end of a C program, we'll close out the handle. So we'll call close handle on all the elements in that array of handles. Okay, and so that Boolean right here, this true, is if we're going to wait for all of them, right? So we set this true as it says kind of here. It says bool b wait all is the actual name of that argument, and so we'll wait for all of them if we set this to true. And again, infinite to wait forever. So that's going to do it. So let's go ahead and run the code. So let's go ahead and first rebuild. Right there, we'll do rebuild. Okay, succeeded. And I put a breakpoint in here just so we can see the output. All right, so there we go. So here we have it. So we didn't have to do any mutex locking. That was done basically for free for us because it's a thread safe function, so we didn't have to implement the synchronization. We just waited down here until all the threads were finished, but the printing itself we didn't have to worry about. And we can see that they come in kind of a different order. So it's not 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. In this case, it's 0, 1, 6, 3, 2. But this order isn't static, right? So if we run it again, we had 0, 1, 3, 6 last time. Now we have 4, 6, 8, 5, 7. Okay, so that's similar things, hold up. So when we use the standard libraries version of thread, we saw the similar type thing, except when we did cout, that wasn't thread safe. And in this version, we're using thread safe functions. And we're using a specific implementation of threads. So not a higher level abstraction away from the actual threads. We're using the actual API for Windows. So that's going to do it for today. That's our example for basic threads in Windows. We're doing more examples on this, on pthreads, OpenMP, MPI, etc. Just to kind of get used to the different environments and the different ways we can actually do multi-threaded stuff and kind of weigh the costs and benefits of this. So just as kind of a quick recap, with thread, we abstracted everything away, and but it made it really easy to use, but kind of more difficult to control. And over here, it's much more difficult to kind of get up off the ground and running with it. But we have a lot of control, like down to the level where we can specify the stack size for a specific thread that we create. So if we go on the GitHub page at github.com/coffeebeforearch, we've got links to all the series that we do here. So in this case, we're looking at practical parallelism in C++. Then we've got Windows threads right here. So feel free to download this project, play around with it. If you have any problems, just let me know, and I'd be happy to try to help you out with anything. Or if you have a specific example that you maybe would like to have featured on the series, just shoot me a message. All my contact information is on this README right here. So check out the other videos down here or the other files if you're interested in those. And like I said, I'm Nick from Coffee Before Arch, and I hope you have a nice day.